సో ఓకే బా ఏంది పొద్దున్నే వస్తుందా? నేను లేట్. సో so yesterday I said you about so decorators. So next we'll talk about working with the closers. Okay. So let us talk about closers here. Now these closers are so related with nested functions only. Okay. So closers. So closer is a closer is an inner function. Closer is an inner function. What is a closer is an inner function which performs operation using the data of outer function. See, closer is an inner function. What is a closer is? A closer is inner function which performs operation using which performs an operation using outer function. Okay, closer is an inner function which performs an operation using what here? Outer function. Okay. So what is the meaning of this here? So it is an inner function. It is an inner function and which performs operation using the data of which function? Outer function. Okay. So it is like this. So this function returns this function returns this function returns inner function. This function returns inner function. This function returns inner function here. So what is this exactly? Closer is okay. So this is a syntax of writing a closer here. So what is the syntax is? You're writing like this. So definition, function name. Okay, so it is having some arguments. You can write any number of arguments and you can write different types of arguments. And then you write another function. And this function performs operation. Okay, this function performs operation using the data of outer function. So this is writing multiple statements. Okay, and you can even have the statements in inner function. So here these are the statements which are there in outer function. Okay, yes. So closer is an inner function which performs operation using the data of outer function. So what is exactly the meaning of it is? For example, just try to see here. So when you go for a closer is, if you want to perform the same operation, if you want to perform a different operation using the data of using the same data, if you want to perform different operations using the same data, if you want to perform different operations using the same data, for example, So there is one function. Assume that there is one function called power. So power is a function. This function receives the number as well as power. So result equal to num to the power of p. And after finding the result, you are returning this value. You are not printing the value. What you are doing? Returning value. Print means it will print on a console. Okay. Yes. So this is a function main here. I want to find the power of same number but different powers. So result 1 equal to power of 5 to the power of 2. Result 2 equal to power of 5 to the power of 3. Result 3 equal to power of 5 to the power of 4. Result 4 equal to power of 5 to the power of 5. But in this, one is same. Which one is same? 5 is a same, but only you are changing which one only power. So first you are finding the power of 2 and then 3 and 4 and then what? 5. So here number is the same. Number is what here? Same. So 5, 5, 5 and 5. But which one is changing here? Power. That is 2, 3, 4 and 5. 5 to the power of 2, 5 to the power of 3, 5 to the power of 4, 5 to the power of 5. Like that. So the function is same. But you are calling, it means you are allocating memory for this 5 whenever you call the function. You are allocating memory for the 5 whenever you call the function. How many times memory is allocated whenever you call the function? The memory for number and power is allocated. Whenever you call the function, the memory for number and power is allocated. Whenever you call the function, memory for number and power is allocated. Whenever you call the function, the memory for number and power is allocated. But I want to allocate memory for number only once. Only once. And same number, I want to find the different powers. Then what will I do is, here outer function will receive number. Outer function will receive number and inner function will find a power of that number. Outer function receive the number. See here. Outer function will receive the number and inner function will find the power of that number. So that how many times memory for this number is reserved? Only one time. So result equal to num to the power of p. Result equal to num to the power of p. And after that I'm saying return result. Return result. And I said closure is a inner function which return closure is a function which returns inner function. Closure is a function which returns what? Inner function. It is returning which function here? Find a power. For example, I want to find a power of 5. So this is power of 5 equal to power of 5 equal to, I'm calling the function power by sending 5. So what this power function will receive? 5. This power function will receive what here? 5. After receiving 5, it will return which one? Address. It will return the address of which function? Find power. So what find power? Power of 5. Okay, it is returning address of which one? Find power into which variable? Power of 5. Power of 5. So what I'm saying is result 1 equal to power of 5 of 2. It means this is nothing but 5 to the power of 2. So you are calling which function here? Inner function. Okay, because power of 5 is holding the address of find power. So 2. Now 5 to the power of 2. 5 to the power of 2. That result is written into what? Result 1. In the same way, I want to find another result. So I'll say result equal to power of 5 of 3. result 3 equal to power of, okay, power of 5. Power of 5 of what? 4. It means power of 5 is a function which finds the power of 5. Suppose if you want to find the power of another number, I'll say power of 9 equal to power. I call the power function by sending the value 9. By sending the value 9. So what will happen? It will return. What it will return? Find the power function. So find the power function will find the power of which one? 9. So I have to send only power. Okay, I have to send only power. Result 1 equal to power of 9 of 2. Okay, result 2. Result 2 equal to power of. Result 2 equal to power of 9 of 3. So this time, what is the number is holding? 9. So this is receiving which one? 2. So that is nothing but 9 to the power of 2. This is receiving which one? 3. That is 9 to the power of 3. If you want to find the power of 5, again, you can say result 4 equal to power of 5 of 5. This is nothing but 5 to the power of 5. Because this is which function? Power of 5 function. And this is which function? Power of 9 function. This is which function? Power of 5 function. This is which function? Power of 9 function. So if you want to perform same operation, you want to perform different operation using the same data, then you go for which one? Closures. Then you go for which one? Closures. So closure is an inner function which performs the data using outer function. Closure is an inner function which performs operation using data of which function? Outer function. So see the same thing here, power, and there is a number and there is a finder which receive the power and result equal to num to the power of p and return the result, and outer function is returning which function here? Inner function. So I want to find power of, or power of 5. Power of 5 function I'm creating power of 5 function. Find the power of 5. Result 1 equal to power of 5. Power of 5 of 2. Result 2 equal to power of 5 of 3. I try to print result 1 and result 2. So power of 9 equal to find the power. Okay, find the power of 9. Result 1 equal to power of 9 of 2, and result 2 equal to power of, okay, 9 of 3. So there is a result 1 and there is a result 2. So how many power functions I created? 2. One is for finding the power of 5. One is for finding the power of 9. One is for finding the power of 5. The other one is finding the power of 9. So once you run this, find the power. So this is power function, right? So outer function returns inner function. 25, 125, 81 and 729. So performs operation using, performs an operation using the data of order function. So that will avoid allocating memory for the same data again and again. That avoids allocating memory for the same data again and again. It means you can generate different functions for finding different powers for the same number, for finding the different powers for the same number. For finding the different powers for the same number, you are trying to go for which one closest, right? Okay. Okay. Now, I'll tell you one more example here. Let us see another example here, how this will work exactly. Okay. For example, there is a function, okay, there is a function called, simple example, there is a function called calculator. Okay. So the calculator is a function which receive two numbers. I want to create a calculator with two numbers, and on the same numbers, I want to do different calculations. Same numbers, I want to do different calculations. Different calculations on the same numbers. Okay. So what I'm doing, I'm trying to write one more function here, calculate. This calculate function receive the operator. Okay. So this is closer is a function, inner function, which perform the operation using a data of which function, outer function. Now calculator is doing calculations using the same data, same data. Okay. So if operator is a plus, okay, I'm saying return n1 plus n2. Okay, if operator is a minus, else if operator is a minus, else if operator is a minus, what I'm saying return n1 minus n2. Else if operator is a star, else if operator is a star, return n1 into n2. Else if operator is a slash, else if operator is a slash, I'm saying return n1 slash n2. Okay. Then what calculator is doing is it is returning calculate function. Calculator is the outer function is returning which function? Calculate function. But calculator is receiving numbers and it is returning calculate. Using this calculate, you can do different calculations on the same numbers. Using this calculate, you can do different operations on the same numbers. Okay. Suppose I try to create a calculate here. For example, calc 1. Calc 1 equal to calculator. I just write here 10 comma 5. 10 comma 5. Now it will create a calculator with how many values? Two values. Okay. It will create a calculator with two values. What is the value of n1? 10. What is the value of n2? 5. And then return which one? Calculate. So calc 1 is holding which function? Calculate function. Calc 1 is holding which function? Calculate function. And this calculate function using which data? 10 and 5. See, it is using n1 and n2. It is using 10 and 5 to do these operations like plus, minus, star, and one more is what? Slash. Suppose if I'm saying result 1 equal to calc 1, I'm doing which operation? Plus. Calc 1 means it is calling which function? Calculate function by sending which operator? Plus operator. And then our operator is a plus. What is n1? 10. What is n2? 5. Written which one? n1 plus n2 is written into what? Result 1. Okay, result 2 equal to calc 1. I want to perform the operation called multiply. But is it data is the same? Data is the same but different. Data is the same but different operations. Data is the same but different operations. I create calculator 2. Calculator, this time I'm saying 5 comma 2. This is a calculator created with how many numbers? Two numbers. On these two numbers, I can do different calculations. On these two numbers, I can do different calculations. That is calculator 2. I want to do operation called plus. I can say calculator 2. I want to do the operation called division. calculator 2, where I want to do the operation called which one? Multiply. So then print result 1, result 2. This result 1 and result 2 is belongs to which one? Calculator 1. And result 1, 2, 3 belongs to calculator 2. R1, R2, and one more is what here? R3. R1, R2, and R3. Okay. Yes. So once you run this, there is a 15. There is a 15 and 50. Okay. And there's one more 7.2, 7, 2.5, and one more is what? 10. So if you want to perform same data but different operations, you don't want the memory for this data to be reserved every time. You don't want memory for this data to be reserved every time. You don't want the memory for the data reserved every time. You want the memory for the data to be reserved how many times? Only one time. And should be used how many times? Number of times. Okay, right? So in that case, you can go for this closures. Okay. So this is a result 15, 57, 2.5, and one more value is 10. Suppose I'll tell you one more example. So there is a function called some draw line. Okay. Again, if you take one more function, draw line receive the character. Okay, draw line is a function which receive the character. Okay, draw line is a function which receive the character and draw the line using a function called draw. But using the same character, it will draw the line with a different lengths. Using same character, it will draw the line with a different length. So draw is a function which draw the line by repeating this character L times. By repeating this character how many times? L times. And return, which function you are returning? Draw function. For example, I want to draw the stars. Okay. Now I'm creating stars, draw stars function. Draw stars functions. Draw stars function equal to draw line. So I want to draw the line using which one? Stars. Okay, I'm creating another function called draw. Okay, draw dollars. Okay, draw dollar equal to draw line. I'm trying to draw it by using dollar symbol. There is a two functions now. So first one returns draw function, and the draw function will draw which one? Stars. Second one, draw line, receive the character and return which function? Draw function, that will draw which one? Dollars. That will draw dollars. Suppose if I want to draw the stars in my application, if I want to draw the stars, I'll just write draw stars with the length. So what is the length I've given? 10. So length is 10. Repeat this character how many times? L time. But what is the character here? Star. Then I'm saying draw stars, some 40. Repeat the stars how many times here? 40 times. And there is a draw dollar. There is a function draw dollar and repeat this dollar how many times? 20 times. There is a function called draw dollar and repeat this dollar how many times? 30 times. So repeat this stars how many times? 10 times. Repeat the dollar how many times? 40 times. Sorry, stars again 40 times. Yes. So the inner function which performs, yes. Now this is stars and this is what? Stars again. This is a dollars and this is again which one? Dollar. So how many functions I created here? Two functions. One is for drawing the stars and one is for drawing the dollars. So it means outer function is receiving character and returning what? Inner function. So that inner function will draw which one? Stars. And outer function will receive the data and return the inner function. That inner function draw which one? Dollars. Okay, right. It's a dynamic. This one is a dynamic here. This one actually call it as dynamic behavior of it. This is called as a closures. I said using inner functions, you can develop some special functions like what is that yesterday I said. Okay, using inner function, you can develop some special functions like closers, decorators. You can develop some special functions like closers and what? Decorators. So there is a decorators and there is a closers and there is another function which is called as generators. Generators, okay, generator is also one special function in Python. Generator is also one special function in Python. Generator. This is about closers. See, this is I've given some examples here, like what is a closer and how it will work, right? Okay. Then there is one more special function you have in Python. There's one more special function you have in Python and that is generator. There's one more special function you have in Python and that function is what here? Generator. So generator is a special function. Generator is a special function. Generator is a special function. The name itself, right? Generator is a special function which return generator iterator object. Okay, which returns generator iterator object. Generator iterator object. And this object is used. This object is used for generating what? Values. For generating values. For example, range is there. Now using range, I can able to generate a sequence of values. For example, if I'm saying range 1 comma 21 1 comma 11, so this range will generate how many numbers? 1 to 10 numbers, 7, 8, 9, 10. If I'm saying range 10 comma 0 comma minus 1, so this will generate values from 10 to 9, 10 to 1. Okay, 10 minus 1 is 9, 9 minus 1 is 8, 8 minus 1 is 7, 7 minus 1 is 6, 5, 4, 3, 2, 1. So range, if I'm writing some 1 comma 11 comma 2, so this will generate 1, 1 plus 2 is a 3, 3 plus 2 is a 5, plus 2 is a 7, plus 2 is a 9. So range is there. Range is there for generating sequence of values. But range, there is some limitations of the range. When I'm talking about range, where in range you can give start, stop, and step. That's all. In range, you can give a start, stop, as well as what step. What you can give in the range is start, stop, and step. In the range, you can able to give only a start, stop, and step. What you can write in the range is what you can give in the range is start, stop, and step. That's all. You can give only start, stop, and step. Okay. But suppose I want to generate a sequence of prime numbers. I want to generate a sequence of which numbers? Prime numbers. I want to generate prime numbers. Can I generate prime numbers? Using range, can I generate prime numbers? No. Because range will accept only start value, stop value, and step value. That's all. Increment value, decrement value, series. You can create a series of a numbers where you can tell the difference, different between the values. Where you can tell the difference between what values. But using range, I cannot generate my custom range values. I cannot generate custom range values. I cannot generate. Now I want to generate factorials. I want to generate factorials from 1 to 5. I want to generate factorials. Can I generate it using range? No. I cannot generate it by using what? Range. Then how can I generate it? For that I have to develop my own. I have to generate, I have to create my own function, which will generate my own values. So you can say generator is the custom range. Generator is a custom range which allows you to generate your own sequence of values. So generator is a custom range. You can say custom range function which allows to generate custom defined, means user defined sequence of values. Custom defined or user defined, custom defined or user defined sequence of custom defined or user defined sequence of values. So if you see the definition of generator, technical definition of generator, it is like this. If you see the technical definition of generator, it is like this. So what is a generator here? Yes. So it will return iterator. Generator function returns generator iterator object. This is a Python definition of generator. This is a Python definition of generator. A function returns generator iterator object. Using iterator, you can read the values. It looks like a normal function. It looks like a normal function, except that it contains which expression? Yield expression. So generator function, how it will generate the values? By using yield keyword. Generator function, how it will generate the values? Using yield keyword. How it will return the values? By using yield keyword. Yield. We will see this yield expression for producing for producing series of values usable in a for loop, that can be retrieved one at a time with next function, because how iterator can iterate how iterator can iterate the values by calling which function, next function. You can read the values by you calling which function, next function. Okay, next function also you can use it. But how generator function will return value? By using one keyword called which one, yield. So what is generator iterator object? An object written by, what is generator iterator? An object written by, what is generator iterator? What is generator iterator is an object written by generator function. The object written by generator function is called generator iterator. An object written by generator function is called generator iterator. An object created by generator function is called generator iterator. Now using this generator iterator, you can iterate values or read the values. So what is generator expression here? See here. What is generator expression? This is generator expression. Okay. But that is generator and generator iterator. But every function is not called as a generator function. Which function is called as a generator function? Which return the value by using which keyword? Yield keyword. There is a yield keyword. Yield is a keyword. Okay, yield keyword. Yield is there. Now you are using yield keyword. Yield is a keyword. So it will pause. Where is that here? Somewhere. Yield keyword. Okay, yield statement is syntactically or semantically equivalent to what yield expression. The yield statement can be used to omit the parenthesis that would otherwise equivalent to yield expression. And what yield will do is yield expression and statements are only used when defining generator function and are only used in the body of the generator function. Using yield in a function definition is sufficient to cause the definition to create a generator function instead of what, normal function. It means the function which is having yield keyword, that function is treated as what, generator function. The function which is having yield keyword is treated as or is defined as what, generator function. Okay, if the function is having yield keyword, then only that function is treated as which function, generator function. But what yield will do is yield return value and pause. Okay, yield return value and pause execution of function. Pause execution of function by remembering by remembering the state of the function where it is paused. State of the function where it is paused. When iterate next value, it resumes back where, okay, where it paused, where it is paused the execution of, where it is paused the execution of what, function. So the function which is having yield keyword is defined as a generator function, and yield return value and pause execution of function by remembering state of function where it is paused, where it is paused, right? When iterate next, when it iterates next value, when it iterates next value, it resumes back where it is paused, where it is paused, and pause the execution of function. Where it is paused the execution of which one? Function. So that is done by yield keyword. But return is a keyword which terminates the execution of function. Return keyword after returning value terminates execution of function, but yield keyword doesn't terminate the execution of function, but rather than what will happen? Pause it. Rather than what will happen? It will pause it. Just to see it. Just to try to see this one. Generator function. Suppose generator function. Name of this is generator function 1. Generator function 1. And this generator function 1 generates some values. I'm saying yield. Yield some 10. Okay, I'm saying yield. I'm saying 5. I'm saying yield some 9. I'm saying some yield. Yield some 19. I'm saying yield. Yield. I'm saying 23. I'm writing here yield. Okay, some 27 like this. So generator function 1. So this generator function 1 is able to generate how many values? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now generator iterator. Now generator function returns which one? Generator iterator. Generator function returns which one? Generator iterator. So I'm saying generator function 1. So what it returns? Generator iterator. If you want, you can print it. You can print what this generator iterator is. So this is a variable, right? What this variable returns? Generator iterator. You can see generator iterator object of which function? Generator function. So how can I read the values? I can read the values by using for loop, or I can call which function? Next function. Next function of generator iterator. When you say next, what will happen? It will return. If you are writing a next, what will happen? It will return next value. What will happen? It will return the next value generated by this function. What is the next value here? 10. So after returning 10, it will pause. After returning 10, what will happen? It will pause. It will pause the execution. After returning 10, it will pause what here? Execution. It will pause the yield will not terminate, but return will return the value and terminates. But yield will not terminate. What yield will do? It will pause. Yield will not terminate. Yield will pause. Pause the execution of function. Yield will pause the execution of function. It will not terminate it. It will not terminate. It will pause the execution of function. It will not terminate. It will pause the execution of what? Function. It will not terminate. It will pause the execution of function. It will pause the execution of function. So after returning value 10, it will pause. And remember where it is pause the execution. Where it is pause the execution. Now when you read the next value, by saying generator iterator. So it is paused here. From where it will continue from next line. What is the next line? Again, I said yield 5. So 5 is written. After returning 5, what will happen? It will pause. It will pause the execution of what here? Function. It will pause the execution of function. Now, what is the first value? 10. What is the second value? 5. What is the first value? 10. What is the second value? 5. You can give this to the for loop for value in generator iterator. For value in generator iterator, and you can generate all the values. So that is 19, 23, and what? 27. So this is creating generator iterator object. This is creating generator iterator object. So generator function returns which object? Generator iterator object, and using this iterator you can iterate all these values. But at a time you can read how many values? Only one value. At a time you can read how many values? Only one value. Can I convert this into the list? Generator iterator equal to generator iterator function 2. I'm saying list 1 equal to list of generator iterator, and then I said print list 1. Print list 1. Print list 1. I said print list 1. List 1 is having the values generated by generator function or not? Yes. How many values it is generated? Like 10, 5, 9, 19, 23, and what? 27. How many values it is generated? 10, 5, 9, 19, 23, and 27. These are the values generated by which function? Generator function 1. So yield is a keyword. Yield keyword will not terminate. Yield keyword will pause the execution of function. Okay, yield keyword pause the execution of function, and the function which is having yield keyword, only that function is treated as which function? Generator function. Okay, if yield is not there inside the function, then it is not called as a generator function. Then it is not called as a generator function. If yield keyword is not there, then it is not called as generator function. So you can generate custom defined numbers. For example, I want to create a prime generator. So what is this function here? Prime generator. I want to generate the prime numbers from given range. So m is a start value, n is a stop value. I want to include start value as well as what? Stop value. So I want to generate all the prime numbers from m to n. I want to generate all the prime numbers from m to n. Okay, I want to write a generator function. I want to write a generator function. So what I can do here is I should generate the values from m to n. M should be included, n should be included. So for number in range m comma n plus 1, m comma n plus 1. So it will generate all the numbers from m to n plus 1 or m to n. From this, I have to generate only which numbers? From this, I have to generate only which numbers? Prime numbers. Then I have to find out, is it that is a prime number or not? Okay, suppose if I'm writing, suppose if I'm writing prime, okay, prime generator 1 equal to prime generator 1 equal to prime generator some what I'm saying is some 5 comma 50. Now I want all the prime numbers from 5 to 50. What is m value? 5. What is n value? 50. From 5 to 50, I have to I have to generate all the prime numbers. So this range will generate all the values from 5 to 50. But from 5 to 50, you should generate only which numbers? Prime numbers. From 5 to 50, you should generate which numbers? Prime numbers. Then you have to find out for I in range of 1 comma number plus 1. Means you are dividing this number from 1 to number. If number mod I equal to 0, count plus equal to what? 1. This is the logic of prime number. Okay, so every time you are reading a number and you are finding that number is a prime or not. If it is a prime, you should generate it by saying yield number. If it is a prime, you have to generate it by saying what here? Yield number. Okay. So prime 1 will generate how many prime numbers? From 5 to 50. So what is the value of m? 5. What is the value of n? 50. So this will generate all the values from 5 to 50. This will generate all the values from 5 to 50. 5, 6, 7, 8, 9, 10, 11, 12, 13, okay, 14, like this. It will generate up to what here? 50. But from this, I have to generate only which numbers? Prime numbers. What is the first number here? 5. You have to find out whether 5 is a prime or not. If the 5 is a prime, then you are generating that number. And then what is the next number? 6. Is it 6 is a prime or not? If it is a prime, you have to generate it. When I should write here, if the count is a 2, then only it is a prime. Okay, if it is divisible with 1 and itself. If the number of factors are 2, then I'm saying generate that number, because that number is which number? Prime number. If the count is a 2, then only you're generating that number. If the count is not a 2, you're not generating, because the number which is divisible with 1 and itself, that you call it as which number? Prime number. The number which is divisible with 1 and itself is called a prime number. Now this is prime generator. Receive m value is 5 and n value is what here? Yes. Then what I can do for number or n in prime 1. So now you can see n, I want to print in the same line. I call the function main. Now you can see 5, 7, 11, 13, 17, 19, 23, 29, 31, 41, 43 and what? 47. All these are which numbers here? Prime numbers. You can create your own ranges. Okay, prime 2 equal to prime generator. Prime generator, I can give the range from 1 to 20. I want to generate all the prime numbers from 1 to 20. For n in prime 2, and then print which value? N value. So this will generate prime numbers again. So I want in the next line. So after this, insert one new line. You can see 2, 3, 5, 7, 11, 13, 79, 19, 19, right? Okay. So it is nothing but customized, it is nothing but customized range function. It is nothing but customized, which function here? Range function. Customized range function that you are doing it by using generators. So it is a prime generator which will generate the prime numbers. Prime generator which generates the prime numbers. Okay, yes. But generator function should have which keyword? Yield keyword. Then only it is treated as a generator function. But if you are not writing that, then it is not treated as what? Yield. I mean, generator function. Suppose factorial generator. I want to generate all the factorials from m to n. Okay, suppose I want to generate factorials from 1 to 10. For each number, I want to generate one factorial, right? Then what I'm saying, factorial generator. So for number in range m comma n, m comma what is that? N. Then I have to find out the factorial. I should include n. Then n plus 1 I've taken. I want to find the factorial for number, right? So factorial equal to 1, because if the m is 0, then 0 factorial is what? If m is 0, then 0 factorial is what? 0 factorial is what? 0 factorial is 1. Then 0 factorial is what here? 1. Okay. Yes. Then for I in range of 1 comma number plus 1 and factorial equal to factorial into I. You are multiplying all the numbers. Suppose if number is 5, 1 into 2 into 3 into 4 into 5. Okay. Yes. Then after that return or yield. Okay, yield. Which value you are printing, returning? Suppose factorial generator 1 equal to factorial generator. I want to generate factorials from 2 to 10. I want to generate factorials from 2 to 10. So factorial generator receives how many values here? 2 values. So the value of m is 2. The value of n is what? 10. And I want to generate the factorials for some number in factorial 1, and you can see these are factorial numbers. These are which numbers? Factorials from 2 to 10. These are the factorials from 2 to 10. You can see 2 factorial is 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, 6 factorial is 720, 5 factorial is 5040, 6 factorial is 40,320, like that. But we get all the factorials from 2 to what? 10. So 2 is included as well as 10 is also included. Say 2 is included and 10 is also what? Included. 2 is included and 10 is also included. So that will generate factorials of all the numbers. So if you want to have a custom range, right? If you want to have a custom range, if you want to have a custom range, so that you can do it by using which function? That you can do it by using which function here? Generator function. That you can do it by using which function? Generator function. generator function, which is used for generating custom defined values. Used for generating custom defined values. Okay. Now I want to generate, for example, I want to generate a power series. I want to generate the series which contain the power of all the numbers. Power of all the numbers from M to N. I want to generate the power series. I want to generate the power series from M to N. So where I'm using for number in range M comma N plus 1, because I want to include N. So what I'm saying is here is I'm just writing yield. Yield num to the power of what? 2. Yield num to the power of 2. So this will return power generator. This will return power generator equal to power series. So this will create generator iterator object. This will create generator iterator object. This will create a generator iterator object. So I have to give m value. So m value is 1, n value is 5. Now this power series generate the series from 1 to 5. Power series 1 to 5. So for value in power generator, so print what I have to print here? Value. What I have to print here? Value. Value I have to print it. What I have to print here? Value. So you can see. So 1 to the power of 2 is 1. 2 to the power of 2 is a 4. 3 to the power of 2 is a 9. 4 to the power of 2 is a 16. And 5 to the power of 2 is what? 25. So it is nothing but generating sequence of values only, but customized. Generating sequence of values only, but customized. Generating sequence of values only, but custom generated. For example, I want to generate passwords. I want to generate OTP numbers. I want to generate passwords. I want to generate what? OTP numbers. Then I can write OTP generator. I can write OTP generator that should generate what? OTP numbers. I can write OTP generator that should generate what? OTP numbers. So there is a password generator that should generate what? Passwords. Password generator should generate what? Passwords. OTP generator should generate what? OTP numbers, right? Suppose OTP generator. I want to generate 3 OTP numbers. So OTP generator. This OTP generator should generate how many OTP numbers? 3 OTP numbers randomly. For that, I import one module called random module, because to generate a random number, I just import one module here. What is the module I imported here? Random module. And it should generate how many OTP numbers? 3. So this for loop is executed how many times here? 3 times. Then what is the size of OTP number? What is the size of OTP number? 4 digits or 6 digits. 4 digits are what? 6 digits. That is the size of OTP number. So I take all these digits. First 4 digits. Okay, digit 1. So random is a module, and within random module there is one function called random integer. So this will generate one random integer from 0 to 9. Random integer is a function which generates one random value from 0 to 9. Or I can write directly. Okay, you want 4 digits, right? I start with 1 and end with what? 9. So what this will do? It will generate one random value from 1 to 9, and that value I'm returning it. This is OTP. I'm saying yield. Yield, what is that? OTP. Yield OTP. So OTP generator equal to OTP generator. So this will return generator iterator object. So it will generate one random value from 111 to 4 ones to what? 4 nines. One value it will generate between what? 4 ones and 4 nines. So I want OTP number 1. OTP 1 equal to next of OTP generator. Next of OTP generator and print OTP 1. Print what is that? OTP 1. Print OTP 1 once I run this. What is the OTP number? 4996. If you run this again, you get another number because the number is what? Random. The number is what here? Random. You want two OTP numbers. OTP 2 equal to next of OTP generator. So print OTP 2. If you want another OTP number, OTP 3 equal to next of OTP generator, and this is what? OTP 3. Because your OTP generator generate how many OTP numbers? 3 OTP numbers. This is OTP number 1 and this is a 2 and this is what? 3. But can I generate one more OTP number using this? No. Because is it iteration is exhausted or not? Yes. Because your iterator generates only 3 OTP numbers. Now you can see stop iteration. Why it is stop iteration? Because is it any more values to iterate here? No. There's no more values to iterate. Then it stop what? Iteration. There's no more values to iterate it. Then it stop what here? Iteration. Okay. So generators are used for generating custom defined values. Custom defined values. For example, I want to generate account numbers. I want to generate roll numbers. I want to generate account numbers, roll numbers, employee numbers, account numbers, roll numbers, employee numbers, passwords, usernames, user IDs. Then I can do that by writing one special function called what? Generator. You can see 140. By using one special function, that special function you call it as what? Generator. Now 891927192338. Okay. Yes. Okay, right? This is how you work with the generator function. So generators, closers, and decorators. Generators, closers, and what? Decorators. So yesterday we have seen decorators, and we have seen closers, and we have seen what? Generators. Then the next we'll talk about recursion. Function what? Recursion. But that we'll see in the next class. And tomorrow there is no class, right? Yes, tomorrow there is no class because of some work, right? So next class will be there on Monday, right? So there's no class tomorrow. Next class will be there on Monday, right? Yes, we'll stop it here and we'll see you on Monday. Right. Thank you. I say no. Written means it will not print, right? Written means print. Function one, print. Print hello. Print hello means hello will be printed on console. If I run this, hello is printed. Okay. But if I say written hello, will it print up? Written hello means will it print? No. Written hello means will it print? No. Written means not printing. So it will return this value. And this value should catch here. You should assign that value to one variable. That value you have to assign to one variable and that you are using it. This value you are using in this function. This value you are using inside this function. This value you are using inside this function by returning it. Okay. So that is a difference. Okay, now Krishna Veni. Okay. Hmm? Hmm. ఏం చేయాలి నిన్న రాలేదా